ethanol. Ethanol. It have a system name called ethanol, and you also have a common name called alcohol. Alcohol is the general public use, and system name ethanol is the chemist use. Now let's look more detail. Now let's look onto this 2C product. Ethane single bond, ethene double bond, ethanol 2C with a OH. This OH, pay attention. Student, you require to know the name, the structure formula, and the structure. Now we talk naming of this hydrocarbon. Like methanol is the 1C hydrocarbon with a OH. Ethanol 2C with a hydrocarbon with a OH. Propanol 3C hydrocarbon with a OH. So all the alkanol, all the hydrocarbon with a OH, they come from the alkane, but adding with a function group OH. And you can represent by a general formula, ROH. What is R? All the hydrocarbon group with adding a OH function group. And that's how the way you're naming alcohol. Ethanol have three main use. Used for alcohol beverage, as a solvent, and as a fuel. Student, you require to know the structure, to how to draw the structure of ethanol, as well as the formula, C2H5OH. So please learn this properly. Now let's look onto the physical property of all this alcohol. This alcohol contains a OH group. And this OH group make a big difference because it forms hydrogen bond between molecules. And alcohol tend to dissolve in water, and which contrasts to the early ethene and ethane that we learned. As ethene, they form dispersion force, non-polar molecule. And now it's going to have an OH. So this become a polar molecule. So you change from oil-based become water-based. So they tend to dissolve in water. Now let's compare the melting boiling point. You will find that all the alcohol have much higher boiling point than all the alkane. Alkane have a very low boiling point, and alcohol have a very high boiling point. Why? Now let's look onto the structure. All the alkane, they form dispersion force, which is a weak dispersion force between molecules. So low temperature, they will be able to break this bond and it become gas. And alcohol, it have a OH function group. This OH function group, it form hydrogen bond. It form hydrogen bond together, and so you have much higher boiling point. So you can see alkane compared to alkanol, the boiling point will rise almost 100 degrees different. Student, please know this difference and learn this properly. And now let's look onto the ethanol more closely as the solvent property. If you closely look onto the ethanol structure, you will find it consists two parts. You will have a polar hydroxyl part, it contains the OH. And there is also another part called the nonpolar alkyl part, which contain the hydrocarbon CH3CH2. So that is contain two parts, not one part. Now let's look more closely on each part. If you look onto the hydroxyl part, the OH part, it can form hydrogen bond with all the polar molecule. So it makes it to be a good solvent for all the polar substance. But when you look onto the alkyl part, the alkyl group, which is the non-polar part, or the hydrocarbon, non-polar dissolve non-polar. So it forms disperse force with the non-polar molecule. So it also can act as a non-polar substance solvent. So student, ethanol have a very interesting property that it will have two parts. So it like water as polar, and it also like oil as non-polar. So ethanol have this dual property. Ethanol. Now let's look onto the use as being a solvent. This because ethanol can dissolve both polar and non-polar compound. Ethanol being used as a solvent for many perfume, aftershave, pharmaceutical, industrial plastic, with many different examples. And you were wondering, what's meant by solvent? And now let's explain. Take an example of Listerine. Do you think Listerine is of this substance, is it only made of one product, or it will make of many different molecules? Students would easily assume they must make from many different molecules. How many? I don't know. Could be 100, could be 1,000. Different kind. That's too hard too complex to understand. Fine. But I can generalize to say it must be some part more polar, the other part more non-polar. So I use the red dot to represent those complex molecule which is have more OH, the ones with more non-polar as the bottom one with more hydrocarbon. And now these two groups, the top will be the water base, the bottom will be the oil base. The next question I ask, do they mix? Water and oil don't mix. So what happened? Then they simply separate. They don't mix. And how you're going to make them mix? Well, you have to use solvent as alcohol. At the bottom, that is the picture I'm showing you. In this example, water, I put a drop of oil in the middle. Oil clump together, they don't mix. But now I'm going to put some alcohol in it. And now you see what happened. What is alcohol? Alcohol, the top part have the OH part, which will dissolve in water. You also have the non-polar part, hydrocarbon part, which dissolve in oil. Top part form hydrogen bond, bottom part form disperse force. So it will be able to mix like this. So now this alcohol help those polar and non-polar substance to dissolve each other. So no wonder there is so many different type of product. Because this product, they always will have some polar and some non-polar component. And how you're going to make them mix well? By adding little bit of alcohol, and you'll be able to make them both dissolve each other. And that is the function of alcohol. Thank you.